Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our topic is ground anchors. So in ground improvement techniques, in modifications we are doing n different kinds of techniques we are using. In those, the one of these is the ground anchors. These ground anchors are structural elements used to transmit and apply tensile load into the ground. These ground anchors are essential for stabilizing and supporting various types of structure, including retaining walls, slopes, tunnels and foundations. So the purpose of these ground anchors are stabilize slopes and retaining walls, provide support for excavations and deep foundations, resist uplift forces in structures like transmission towers and wind turbines. So whenever we are placed some transition towers and wind turbines, in that particular cases, the forces, there is a chance of forces to uplifting those structures. In that particular, this is going to resist, these kind of ground anchors are going to resist that uplifting of the structures. So in this applicable, it is used widely in geotechnical engineering for slope stabilization, foundation reinforcement and construction support. In this process, we have a different number of ground anchors are there. Those are mechanical anchors, grouted anchors, rock anchors, soil anchors. So different types of anchors are there. So in the each and every we will see step by step in this lecture. So in these mechanical anchors, are designed to create a anchoring effect within the ground through mechanical means. In these mechanical anchors are designed to create anchoring effect within the ground through mechanical means. They typically rely on expanding, whether they are expanding or screwing mechanism to secure themselves within the soil rock. So in these n different number of examples are there. Few we will see in these. Those are expansion anchors. In these expansion anchors, they are going to design composed of an anchor body that expands when a tensile load is applied. In this, whenever these expansion anchors are pulled, the expansion mechanism, those wedges or cams, whatever, the expansion mechanism engages, increasing the diameter and creating frictional resistance against the surrounding material. So these kind of expansion anchors we are going to use in rock and hard soils for applications such as stabilizing rock slopes, supporting retaining walls and securing underground structures. And also the screw anchors design resemble gained screws with helical plates welded to a central shaft. In this, the mechanism in these screw anchors, the mechanism installed by rotating the anchor into the ground where the helical plates create resistance against the pull-out forces. These kind of screw anchors are going to use, frequently they are going to use in anchoring light structures such as utility poles, fences, these kind of light structures, as well as for temporary works like excavation support. For excavation support, such type we are going to choose these screw anchors. The next one is the grouted anchors. So in this grouted anchors involves the injection of the grout around the anchor to bond it to the surrounding soil or rock. The grout fills voids and creates a solid mass that transfers the load from the anchor to the ground. In this n different types are also there. Those are tension anchors, compression anchors. In these tension anchors, they are going to design to resist tensile forces, preventing the uplift or pulling of the anchored structures. These are going to prevent. In this, the design and installation is on the borehole drill to the desired depth. Anchor, usually a steel tendon or bar, is going to be inserted. Grout is injected to fill the borehole surrounding the anchor and creating the strong bond. In these applications, we are going to apply these kind of tension anchors are used in retaining walls, tiebacks of excavation support, and anchoring foundations of tall structures subjected to wind or seismic forces. Next type of grounded anchors are compression anchors. In this, compression anchor is going to resist the compressive forces. If these are going to tensile forces, these are compressive forces providing the support against the downward and also the lateral loads. In design and installation, similar installation process to tension anchors but specially designed to handle compressive loads. Is also as similar as tension anchors, but they are different because they are going to deal with the compressive loads. In these kind of grounded anchors, we are going to use in foundation support, slope stabilization, and as a part of bridge abutments and retaining structures. Rock anchors. In these, rock anchors are especially designed for anchoring into the rock formations. In rock formations, we are using these kind of rock anchors. They are essential for providing stability and support in the rocky terrains. These are going to design and installation. These kind of, in these, the drilling, a borehole is drilled into the rock to the required depth. In this inserting anchor, the anchor is placed into borehole. Grouting. The borehole is filled with grout to bond the anchor to rock. In this, post-tensioning. Often, rock anchors are post-tensioned to apply preload and also enhancing their performance. To apply the preload and enhancing their performance. In these, applications for these rock anchors are stabilizing the rock slope, supporting tunnels, tunnel roofs and walls, securing foundations in rocky terrains, anchoring dams and other hydraulic structure. These are the rock anchors. They are especially for rock formations. And the next type of anchors are soil anchors. They are going to design for use in various soil types and often involve in a grouted bulb or plate to increase the holding capacity. So in this design and installation, drilling or driving, these are boreholes are drilled or anchors are driven into the soil to the desired depth. So in this, we are going to driven into the soil to the desired depth. That required depth, it depends upon the how much the water, groundwater level and what are the requirement. These are the parameters they are going to involve in particular desired depth. So inserting anchor, they are going to placed in the borehole or driven into the required depth. So if applicable, we are choosing this grouting also for these soil anchor types. If applicable. For grouted soil anchors, grout is injected to form a bulb or plate that increases the anchor's holding capacity. It is going to increases that holding capacity. In this, what are the various types which are going to involve in soil anchors? Those are grouted soil anchors, helical soil anchors, applications. So already we understood this grouting is if applicable whenever it is required, whenever it is needed. In this, grouted soil anchors involves the injection of the grout from bulb or plate around the anchor, enhancing its load carrying capacity. Helical soil anchor installed by rotating the anchor into the ground. They are going to rotating helical. They are going to rotate like this. They are going to rotate the anchor into the ground where the helical plates provide resistance against the pull-out forces. These applications, the soil anchors are going to apply to preventing the landslides and erosion on natural or man-made slopes. Excavation support, they are providing the excavation support, that too for lateral support to the retaining walls and excavation faces. In foundation reinforcement, it is used to improve the stability and load bearing capacity of the foundations of the soils, and also uplift resistance, providing uplift forces in structures like wind turbines and transmission towers. So these anchors are critical components in geotechnical engineering, providing necessary support and stability of a variety of structures. It is depends which type of grouting, which type of ground anchor we are going to choose. It is going to understand the different types of ground anchors and their specific applications is essential for selection the appropriate solution for any project or any kind of construction work. So that proper design, installation and maintenance ensure the effectiveness and longevity of the anchoring systems. So design considerations for ground anchors: load requirements, soil and rock properties, anchor length and diameter, corrosion protection. These are the considerations for ground anchors. The load requirements: understanding the tensile and compressive loads the anchor must withstand. In the soil and rock properties, evaluating the characteristics of soil or rock where anchor will be installed. Anchor length and diameter: determine the appropriate dimensions based on load requirements and ground conditions. In this corrosion protection, ensuring the longevity of anchors by protecting against corrosion, especially in aggressive environment. So this corrosion protect it whenever the landslides are there and the soil is very loose kind of hilly regions, they are going to affect whenever the rainfall is happened, and different, they may be flood, different kinds of environmental they are going to there. In that particular aggressive environment, we are going to choose these ground anchors, and based on that corrosion protects which type of environmental is also for understanding the design and choose the better type and giving the materials also we are considering, and also for these are the considerations for the design for the ground anchors. In installation techniques, drilling and grouting, direct installation. So in this drilling, first boreholes are drilled to required depth and diameter. It depends upon the type of the anchor at where we are going to construct this and where it is required. Exactly where it is required. So the drilling boreholes are drilled to the required depth and diameter. In inserting anchor, the anchor is inserted to the borehole. And grouting, the borehole is filled with grout to bond the anchor to the surrounding ground. So in direct installation, for mechanical and screw anchor installation involves drilling or screwing the anchor directly into the ground. Some sort of types of ground anchors are installed directly. It involves drilling or screwing the anchor directly into the ground. Those are mechanical and screw anchors. So this type of installation techniques we are going to follow. In this load testing for ground anchors, for the purpose to verify the load carrying capacity of the installed anchors, it is the very important. Then only we will understand how much withstand of this structure by using this ground anchor, what are we are achieving the expected outcome or not by using these kind of tests. So in this, the purpose to verify the load carrying capacity of the installed anchors. In these methods, pull-out test, proof test, performance tests are involved. So in this pull-out test, we are applying a tensile load to the anchor and measuring its displacement. In proof test, we are applying a load slightly higher than the design load to ensure the anchor can safely carry the required load. So in performance test, monitoring the anchor's behavior under sustained and cyclic loading condition. So these are the tests we are conducting for verify the load carrying capacity. In this also slope stabilization and the location highway cut slope. So in this technique, installation of grouted soil anchors to stabilize the soil and prevent landslides. We are choose the soil anchors to stabilize and prevent the landslides. Because of using such type of location in such type of technique in that particular highway cut slopes, it is improved the slope stability and also safety for highway traffic. And retaining wall support. In urban excavation sites, use of rock anchors to support a deep excavation retaining wall. So in this, whenever we are using these rock anchors to support the excavation retaining wall in urban excavated site, like such kind of case study, the outcome it is the safe excavation and construction of multi-story basement. So what are the advantages and limitations? These ground anchors are very versatile and they are efficient and also cost effective. These are the major advantages which we observe. In this, we can be used in various ground conditions for different applications. And different types of anchors are available: mechanical, grout, rock, soil grouts. So different kinds of types are there. For in that we may choose the conditions are more or also no problem for applying these ground anchors. So that versatility is there in the ground anchors. In efficiency point of view, it provides immediate support upon the installation, immediate effect. In these ground anchors, the project time is going to reduce. So we are using such types of technique for getting the soil improvement, and we want the required desired properties. So in that particular conditions, these ground anchors are helpful without affect the construction schedule. Less effective compared to the remaining some other techniques. And also the cost effectiveness, often more economical compared to other support methods. In this also we are facing some limitations in these installation challenges. It requires the specialized equipment and skilled labor for installation. Corrosion. Long-term durability can be affected by corrosion, requiring appropriate protection measure. Ground disturbance. So in this, drilling and installation can cause disturbances in certain ground conditions. These are some of the advantages and limitations for these ground anchors. In these concerns and mitigation strategies, the corrosion protection using materials like galvanized steel, stainless steel, are applying protective coatings and using sacrificial anodes. In this, quality control, ensuring proper installation through regular inspections and load testing. In environmental impact, minimizing the disturbance to the surrounding environment and adhering to the regulations. In ground conditions, conducting through site investigations to understand soil and rock properties before installation. In future trends, so advanced materials, development of high strength, corrosion resistant materials for long lasting anchors. In innovative installation techniques, automation and robots for more precise and efficient anchor installation. Monitoring technologies, in this real-time monitoring systems to track another performance and detect any potential issues early. So these ground anchors play a crucial role in modern geotechnical engineering, providing essential support and stability for various structures. Their proper design, installation and maintenance are vital for ensuring the safety and longevity of engineering projects. Advances in materials installation techniques and monitoring technologies continue to enhance the effectiveness and reliability of ground anchors in geotechnical applications. These are some of the web references. We are going to understand these ground improvement techniques. Very helpful as per these PPT and also the ground improvement technique slides, and also the NPTEL course is also provided previously. So we may check it. In that also it gives more information regarding these ground improvement techniques. In this, ground anchors are also one of the important topic for understanding. This is the one of the important technique which we are used in versatile way and different kinds of soil condition. It is adaptable. The adaptability of this technique is more. So for getting the desired property. So these are all the things we have to understand in our ground anchors. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.